Okay, in this video we're going to talk about variables. And actually every computer language I've ever worked with has variables. They're a way of storing values away and associating them with a name so that you can bring them back later. So why would you want to do that? Well, a couple of reasons. One is so that you don't have to recompute values, and another one is so you can give a meaningful name to a value. So let's look at variables in microworlds for a second. So in microworlds there are three kinds of variables. There are local variables, global variables, and state variables. And there's something, there are variables that are called local and global in Python as well. And there's something roughly corresponding to the state variables that we'll talk about later in the course when we talk about classes and object-oriented programming. But for now, let's just look at global variables. So if you took my microworlds class, you might not have even heard of global variables in microworlds, and that's because I'm not a big fan. I think you should stay away from global variables as much as you can in microworlds or in any other language. We're going to need to use some global variables in the beginning of this course in Python, but we'll look at ways of avoiding them later on, and we'll talk about why they're not such a great thing in another lesson. But for now, I just want to talk about variables generally. So I'm just going to just to illustrate how variables work in microworlds, so we can compare it with Python. So in microworlds, you can basically, it says a global variable is created with the command make or name. So if you used those before, you know what that's about. It holds its value even when you change projects. In Python, this is not the case. A global variable will be accessible anywhere as long as you're in that particular code sculptor or whatever Python environment you're using. As long as you're working with that particular Python project, you'll be able to access that global variable. But when you finish running, all the global variables go away. They need to be reinitialized again when you start up. Let's see what else. In microworlds, the way you make a variable is with the make command. Let me do this in the Papert logo, just so you can, because it's closer to what goes on in the Python version. So you can do something like make let's say make inches in a foot be 12, and let's make feet in a yard be 3, and now we can make inches in a yard be feet in a yard times inches in a foot. Okay, so this is a way of kind of making it clearer what you're doing. If you just said make inches in a yard 3 times 12, it's not as intuitive necessarily as if you say make inches as a yard in a yard, feet in a yard times inches in a foot. Okay, and then we can show inches in a yard and run normally. Oh, I did something wrong. I don't know how to. Oh yeah, I forgot the colons, didn't I? So in microworlds, we need to put colons in front of our variable names. And that shouldn't have been a quote. That should be a colon as well. Okay, so let's see if this works now. Oh yeah, show is not a command in this version of logo. We need to use print. There we go, 36. So there are 36 inches in the yard. Okay, so and you notice that the way I divided up my word, I don't have any spaces in my variable name. It's very important. You can't have spaces in your variable name. So what I did was, since I wanted to use more than one word, I changed the capitalization. And this is actually a leftover thing I have from doing a lot of Java programming. This is a convention in Java. But Python has a different convention, and I'll show you that in a second. Okay, so let's look at variables in Python. In Python, there are more rules for what you can have for a variable name. So I'm going to, in fact, let me put in a comment that tells you what those rules are. Well, let me go back to microworlds for a second. In microworlds, I have this word procedures tab. If I write other stuff in here, the word procedures tab will just get ignored, and anything else that I write, I think that's the case for this guy too. Like if I wrote, well, no, I'm not going to try that. But the idea is that you can have some text that gets ignored by the Python interpreter or the logo interpreter. And the reason you want to do that is that you might want to write a note for programmers who are trying to read your code. So I could say variables can have letters, numbers, or underscore. That's this guy. All right. Oops, not that guy. Okay. Variables. Now see, in the way you make a comment in Python is to put this hash in front of it, and you can see how the color changes, so you know that this is a comment, and that Python's not going to try to interpret it, and it's not going to try to turn it into computer code or anything. So variables start with a letter or an underscore. Now, starting a variable name with an underscore gives it a special meaning that we're going to talk about later. So for now, we'll stay away from underscores at the start of a variable name. Variable names are case sensitive. So there's a difference between, well, let me put in some examples here. So variables can have letters, numbers, or underscores. So we can have a variable like, let's see. Let's do we can say inches in a foot equals what? 12, right? So now notice that this is a different format from from logo. In logo, you say make, you put a quote in front of the variable name, and then you put the number. In Python, you just put the variable name and say equals 12. So this equals, if you have a single equals in Python, that's an assignment operator. So it assigns the value 12 to this variable. Okay, so this is the same as make inches in a foot 12. So let's just say this is the logo version. Okay, and here's the Python version. And notice the logo version I'm keeping as a comment because it's not going to get interpreted correctly in a Python interpreter, right? So here's the logo version, here's the Python version. Variables start with a letter or an underscore. Okay, actually I'll just leave that there. Okay, and then case sensitive. So what that means is that inches in a foot is not the same as inches in a foot. Okay, these are seen as two completely different animals. Okay, it's as if you spelled them completely differently as far as Python is concerned. What else? Okay, so let's see. So we could have, here's some examples that are illegal. You couldn't write you know, if you wanted to write about a 5-star hotel, you couldn't start it with the number 5, or you can't say, you know, 777 as a variable name. Okay, it immediately gets picked up as a number. In microworlds, in logo, either one of these are okay, which can actually cause a lot of confusion, especially if you make a variable out of something like this. So it doesn't evaluate to 777 anymore. But in Python, this will always be a number, and you cannot have variable names that start like that. Okay. Now there is, let me put a comment in here. So in Python, equals is used like make in logo. So see, we used a make here, and then we have equals. In Python, equals, oh, let's see, like make in logo. Equals is used like equals in logo. So in logo, we'll use equals to see if two things are the same. So if we wanted to do a test to see if, so I say print 5 equals 5, it comes back and says true. Oh, I said print instead of show. I'm getting my prints and mixed up. If I say show 5 equals 5, it says that's true. So it's a similar idea in Python. Where are we? If you want to test if, let's put that down here. You want to test if, let's test if, let's print inches in a foot, and then let's print inches in a foot equals 12. Okay. Let's run that and see. Okay, so we got a 12 for inches in a foot, and we got a true for inches in a foot equals 12. Okay, so this equals just assigned the value to inches. Doesn't, there's no printing going on here. This one prints out the actual value that's found that's associated with inches in a foot. And then, so basically what happens is 12 is stored in a particular location in memory, and then it's associated with this variable name, so that every time you use this variable name, the computer, the interpreter knows to go to that place in memory where the value was stored. So it'll pull out that 12. Okay. What else do we want to do? So that's, oh yeah, so there's certain names that are illegal. Let's do it. I just want to do this because we're going to be looking at it later on. We'll want to convert, let's say we want to convert, oh, I can never remember how to spell this right. Fahrenheit, is that right? To Celsius, I'm going to have to look that up. Let me see. Google Fahrenheit. Oh yeah, that looks right. F-A-H, is that what I did? Let's see. Oh, I had it backwards. Okay. Alright, so convert Fahrenheit to Celsius. So the way we could do that is we could have a variable degrees Fahrenheit, and we'll set it to say 32, because that's we know that's going to be 0 Celsius, right? And say degrees Celsius. So to convert this to Celsius, what we need to do is, we know that Celsius starts at 0 and degrees Fahrenheit starts at 32. So the first thing we want to do is subtract off 32 so that both scales are starting at 0. But we know also boiling, so let's see. So Fahrenheit goes from 32 to 212, freezing to boiling, right? So, so Fahrenheit minus 32 goes from 32 to what, 180, right? Is that, no, it goes from 0 to 180. From 0 to 180, right? So, and we know that Celsius goes from 0 to 100. So we want to change. So after we subtract off the 32, we need to change the scale from going, instead of going from 0 to 180, going from 0 to 100. So the best way we can do that is to multiply by 100 divided by 180. And if you, let's see, if we divide both sides by 20 of this, if we divide the numerator and the denominator by 20, we get a 5/9. Okay, so that'll convert degrees Celsius to degrees Fahrenheit. So let's say print degrees Fahrenheit, degrees Celsius, and see what we get for that. Okay, so 32 is 0. 212 should be 100, right? So I'll change to 212 and check. Yeah, that looks good. Okay, so yeah, so that concludes our lesson on variables.